we studied in terms of revision. I would like to say a few words. Most of you people get it.
Yes, sir.
In the terms of alpha beta pruning, what we want to do, we want to get some output. Either it can be the loser -1, either it can be the +1 winning situation, or either it can be draw situation.
Yes, sir.
Okay. Important thing is this: we should not waste time. There is some kind of a cutting off the extra unnecessary computations, as Noman already explained the computational cost. Basically, it's all about the computational cost. Okay, this basically O is somehow used for the solutions. Okay, here in this formula, this represents somehow computational cost. If you are determining the time factor, this will let us know about this. Branching, cut off the trees, unnecessary trees. Okay. So, if we proceed a little bit further in this scenario, we notice the challenges become more. Okay, you can say that grows exponentially, especially once we are talking the object detection, because mostly in almost all of the fields, computer vision or somehow the audio is okay. One signal represents some kind of audio. The 2D represents some kind of the images. If we have too many frames of the 2D, this represents some kind of a videos. So in the computer vision or the object detection, we are using the computer. Okay, some information, but the problem is there, like the games. Okay, alpha beta game. In order to get the confused state, we need to cut off the unnecessary information. But first of all, we need to eliminate the similarities. Okay. For example, these two cars belong to the same company, Volkswagen. I got this. Okay, you can say that this is present in our Caltech 2011 research article. So both belong. You can notice that even both have the sun roof. Okay, so the side mirror, even almost similar like things. Okay, so,
is also similar.
So most of the similarities are there, but maybe, for example, this one, okay, is not here. So a little bit you can see the differences. You can make it distinguish. So this looks like Sagitar or this one is Rapasan, but belong to the same company. However, if we can notice the natural things are also having the huge amount of the redundance. Redundance means, once we are talking about the redundancy, means the patterns are repeating itself again and again. For example, if we observe the sky on some very clear day, we observe the blue color. If we are taking the picture of it, but somewhere picture has been cropped or deteriorated or somehow removed some part of the picture, we can get it, restore it back from the existing, because the sky data is kind of a redundant. Redundant means the pattern is repeating itself again and again. We can replace, okay, by copy it and paste it by the averaging like this. But the distinguished features are really difficult to know. Okay, to notice. For example, these two birds are totally different, but you can, in the first glance, you can say, oh, both belong to the same species. So the problem is this: the object detection is very much difficult. If we go a little bit further in terms of audio or what, so for the action, what represents some kind of action. This slide I copied from the MIT. Okay, Professor Patrick lecture. So if some word, for example, if I say these are basically what represent some kind of actions. Actions means to do, okay, something that they're doing. We observe the to do things. Okay, for example, if we notice some verb among these, okay, drink, okay, for example, if I show this picture is the Professor Patrick picture, if I am talking about this, what is he doing? Action, what's the verb basically? Action, what do? Drink. Basically, he drinks, okay, we say that the drinking is there, but if I say how many two pictures are similar to one another? Okay. So we can say that, okay, this one is, okay, tossing some kind of, okay, say highlighting, but this is not representing that drinking or maybe showing or whatsoever. But these two pictures are expressing the drinking nature. So both looks are very much different, but the actions are exactly the same. Those species, if I am talking about this cat, okay, also having the two eyes, one nose, one mouth, okay, so drinking the water whatsoever, but the input of the water is almost different, okay, but drinking. Action, verb is what? Because with the help of AI, you need to accurately measure the action or observe the action. The problem is look like this. So we are, okay, we need to utilize the AI data in a very concrete way. We need to cut off, okay, pruning the unnecessary details, but we need to focus, we need to, okay, retrieve the salient, we need to fetch the, okay, get the important details. So if we can see the more application, for example, in the delivery case, if the package is different to the some wrong destination, then it's also the, okay, delivery boy will in trouble, okay, the loss of the finance, all the things. Similarly, if the, okay, the game are like the class scheduling a few people, if the scenarios are the classrooms are, okay, if two, for example, two different course classes are scheduled in the same room, then clashes will be there. So, in order to get rid of such kind of a clashes, you need to make the system very kind of a one should be the winner, one should lose. So, if this should not be occupied, this should not be allocate that particular class, the kind of the, okay, allocation is also kind of the object detection. The formal verification in the ATM machine, the card detection or okay, verification purpose, the person is right, wrong, okay, password whatsoever, are in the entry, okay, level at the certain digital gates. So, right verification is very important stuff. Okay, this also can be done with the help of proper application of the, okay, these pruning, or you can say allow-beta gains or some kind of object detections algorithms. So, if I explain a little bit further in case of, first of all, I would like to say a little bit about object detection. For example, this one object detection. Suppose you are making some company and this company, okay, belongs to the 5% and there are 5%, okay, A, B, C, D, E. There are 5%, maybe A represents some kind of, okay, Aftab, and the B represents Bilal, or E represents somehow Sham. But in these are the basically, okay, 5% represent the data of 5% belong to some particular company. But in case you need to, okay, feed this data in computing system, what you need to do, you need to make an array, and this array of course belongs to some numbers, okay, or you can, of course, first of all, in order to, okay, for making of array, you first need to label. For example, in the numeric value, 1 represent Aftab, okay, 2 represent Bilal, so okay, 3 represent, okay, Chima, Chaudhary, whatsoever, okay, he represent, okay, yeah, Dildar, okay, whatsoever, he represent, 5 represent Iksham. My children, you need to make an array, okay, this is the labeling basically, or the identification. I represent identification, labeling. In case of array, you, okay, of course, this, you need to make some kind of a vector, okay, so this vector should be array, okay, represent one, okay, one dimensional, and it can have n number. It can be 5%, 5 represent n. If 100, 100 represent n. So, my children, you can say this is the 1, 2, 3, okay, 5, or you can say, if I say here, you may see in the books, if there is n, you should not be worried. Basically, the n represents the whole number. So, now these are the 5%. You, okay, made an identification label in form of an array. Next task, what you will do, you need to collect the data. Data collection. For this data collection, you need to get an image of the 5%. Okay, you need to get a maximum number of the images belong to person A, maximum number of the images belong to person B. Why not only the one image? One image will mislead.
Yes, sir.
Why? For example, sometimes I am very much happy, but sometimes I am very much sad. Features become okay different. If there is a white light, my picture, if my picture in the green light, so of course color feature will be changed. Okay, so maximum number of data. Once you will have a data, the data will be augmented, and somehow in the accumulation form, you will get some kind of a net data. So you will collect a huge number of data. For this data, you need to get the intensity image of each person. Okay, so if I'm talking about the intensity image, just I'm talking about the first person intensity image A, and this image you can the person you can say that the one, this one somehow you can say image maybe dimension of this one is the m number of row and number of column, m into n. Why I said it's intensity image?
It is
Pixels.
Pixels. Good. Great. It's okay because in this image we are keeping the values of pixels. Basically pixels are what? Basically pixels are intensity of light.
Yes.
Intensity of light, how? If there is a dark, I cannot see. Okay? And if I want to see with my naked eyes, so there should be a light. What happened? Light reflect from some particular object and reflected my eyes, then I can see that, I can say that this object is like this, okay? Or at least this color of, okay, for example, similarly camera is behaving, okay, follow the, mimic the, okay, a human eye, so capturing the data. So if there is a dark, camera cannot CCD, okay, basically there is a CCD device, the chip like this, and this chip, okay, storing the values, intensity coming from the aperture of the camera. If there is a dark, so no light can be, okay, so disturb it and no light can be stored here. Now, for a moment, if I say I am observing this pen, color of this is what?
Black.
Black. I say, why you said it's black? Because zero light reflected from it. And once you are observing, the color of this page is what? White. Because the 255, this is the zero light from pen, the 255 light somehow reflected from the page. This is the pixel basically. If somehow, for example, this pattern, okay, maybe somehow gray, maybe you can say that there is a, okay, 150, okay, somehow mid value, this is the range of the 0 to 55 of the gray range, okay, gray color range, okay, range of the gray values. 0 represent black, 255 represent, okay, white, so some value inside, in between these, okay, you can say gray or somehow near to the dark or near to the white, whatsoever. This, that's why it is known as the intensity image. And this intensity image in mathematical formation or in the computer language is kind of a matrix. It is very difficult to, if you will have too many vectors in form of a matrix, you need to make, okay, some extraction or the feature extraction where then you need to transform. There should be some function, you need to develop some function, or you can say that the feature extraction factor will transform this image in form of a singular vector. And this vector should be formed, okay, so number of, there are m number of rows, but column only one. And maybe, okay, it's possible that the top, okay, if you are ascending order singular vector, okay, decomposition method, maybe some other thing, maybe 0, 255 at the top, or there, then 250, or maybe 49, 0 at the bottom. So somehow ascending order, it's very easy for you people to determine the features of this, because each color is representing some particular feature. So this is kind of a vector, and this vector is represented, you can say, this is a feature vector. This feature vector, I said that belong to A, image A, person A. But this, suppose this is the image you captured, very happy, okay, mood. But sometimes you will, in the sad mood, you will capture another image of the same person A, the another, you will get the another feature, feature vector. Similarly, maybe 3, 4, maybe, okay, too many images, too many feature vectors, okay, you will get the, okay, same person. Then you will make some kind of a matrix here, and this matrix, suppose this one is the M, okay, So in this matrix, your feature vectors there are too many feature vectors in it, or you can say too many mean the n number of the feature vectors. But remember, each dimension after each is m1, m into 1, number of m into 1. But because there are n number of the feature vectors, overall you can say that the dimension of this matrix is m into n. Are you getting my point?
Yes.
So this is somehow your
feature.
this is somehow you can say that your data matrix in which you are storing the feature vectors. But the problem is this. For example, there are ABC person. There are you at first place, because you are collecting the information at random. As I told you people in the alpha beta games, random data are there. So at first place you are getting the Bilal and you are taking the picture of it. First picture belong to Bilal. Second picture also belong to Bilal. So what will happen here? Your first vector represent to Bilal. Second one also represent to Bilal. How you will identify that this you need to make another vector, and this vector somehow you can say that the identification. So this one is the again array, and this you will store that your first vector feature vector belong to Bilal, second vector also belong to Bilal, somehow third one belong to the Aftab, and the other one belong to the Chiva, and then again blah blah whatsoever. So n number of this one belong to the Etisham, last one.
Yes, sir.
Random.
Yes, sir.
This one is the identification label. This vector represents the identification label array. Now you need to make some kind of a matrix. Or matrix, of course, you are multiplying this vector, and you need to associate these label vector and with the feature vector. So you will make some kind of a mat m. So in this you need to some kind of a data, learning data. This one is a kind of a learning data because we have lot of images belong to particular person and we have associated label with it. So learning feature kind of thing and the labels. So this one, once it will have this one and the other one y into 1n. You are by considering the x and y, you will get some kind of output in form of some learning data, and this learning data will be stored in your system. Now this learning data is stored in your system. Now the job is, first job, pre-processing of data is over now. Until here it's known as pre-processing. Now my children, go to the next step. This next step is what? Sorry.
Can you go back?
Yes, please.
सर हमारे पास सिर्फ 5 ही पर्सन है, तो हमारे पास फीचर एक्सट्रैक्शन भी सिर्फ 5 ही वेक्टर होना चाहिए, ये डुप्लीकेशन क्यों हो रही है सर?
इमेजेस उस तरह
बंदे की हजारों इमेजेस,
वो इमेजेस के हजारों में.
Okay, this image, this feature vector belong to what?
Bilal.
This one belong
Also
to.
Bilal.
Why it is? Why is it? Sorry.
So we have only 5 pictures.
Yeah, no, I am asking why is it? Why is it? First, why is it?
So it's my question, why?
Yeah, why is it? As I said, suppose I am a Bilal. On one day, because you people are studying hard, you are getting very good grades, a good study. You people are become a shining star. You are interactively point out. So sir, what is doing? You have some cunning and the attentive attitude. I am become very much excited and happy. Oh, my students are superstar. If children are doing good, parents become very much happy. This is the natural thing. So like me, I am very much happy. But so my expression, wow. But someday I am visiting the class. No one is in a mood of study. This is my second image. First very happy, second image. So similarly, someday very much tired, someday very much fresh. So lot of images. So now you will store data in form of a pre-processing. So once you are entering in office, maybe you are in any mood, any possible mood. So your face recognition detection system will verify you accurately. That's why we need to collect a huge amount of data. The purpose, if data is huge, accuracy will high. If data is less, even one image is enough. But okay, maybe okay, so 2% can match. Okay, so the problem will be there. So pre-processing data done. No, now at the day of test, okay, for example, you make some kind of a module, okay, some system, the person approaching to the office, okay. So again, the one person out of the A, B, C, D, or E, any person try to approach, or maybe some stranger, outsider, not the 5%, want to enter, okay. So what will the system do first? They will capture its intensity image, and this intensity image, of course, is some kind, you can say that it's the XT, test image. It's the test image. And of course, you will transform, okay, sorry. Okay, here you can say that this one I is the test image. I'm so sorry. No problem. No. Okay. So intensity image, my children, that is the test image at the approaching time. Okay. So.
Sir, what is the idea?
Sorry.
Intensity.
Yeah, actually, I want to say that this is some kind of the intensity. Okay. This is some kind of a matrix of image, test image. Then what will you do with it? You will, okay, make this some kind of the feature. Again, the feature vector. Yes.
Convert 2D array into one.
Okay. So, yes, 2D, you can say that this intensity image is the two-dimensional. We need to transform it to the one-dimensional.
Yes, sir.
Okay, so this is the feature vector.
Yes, sir.
So you will have too many feature vectors, and you will get some kind of this one, okay, this you can say M into N, or you can say this one is the test image. Is it okay? And this test image, of course, similarly like this one, okay, you will have some kind of or maybe single image, okay. If say, for example, I am standing, then you can see that light is blinking, okay, here, for example, let me show this example to you here. This is a, okay, simple laptop. I just want to, okay, see, you can notice that light.
Yes, sir.
Okay, it's opened it, but it's okay blinking too many times to capture my different okay expressions and the features correlate. Then it's opened. Are you getting my point?
Yes, sir.
So say again, it will become.
Come on, sir.
This will become some kind of a okay. Your test image match. Of course, you will have some kind of a label, identification label. Again, after test data, then this one, suppose in this situation you can say
Predicted.
yeah. In this case, you can here your label will there, and
We should predict it, sir.
yeah, we need to predict. Let me explain this, okay? So array of the label that the same person. For example, what will happen here? If I am Bilal, then again Bilal, too many times Bilal.
Yes, sir.
Are you getting my point?
Yes, sir.
So this one will become another. Okay, here at this point, here test. This one becomes again the test image. Okay, test data. Then test data. Okay, of course, learning at the moment. Learning at the moment. And this learning at the moment. Okay, you can say that. Why? Okay, so what I should do? Okay, yes. Now you have this one M sub T, M test, okay, and other one is what?
M.
Here, this one M. This one M is the learning data, and this one MT, okay, here, this one is the test data, which okay, I already stored in this data. Okay, now I have the test data. It reflects. Okay, so what we'll do here? Okay, we already studied a lot in our okay the identification. Okay, or you can say label. Okay, identification. So here you can say that the feature labels matching of the MTM, okay, and this one is what? MT. Now we have two images. One is the data and the M sub T is kind of a test, okay, at the moment. This is observed. This is similar liking. So whatever, if the correlation is too high, that this is matching too high out of the 5, maybe say that this one is Bilal or maybe it's Sham, whatsoever out of the 5. It's a stranger, it will say no match. Sorry, no match. Now of course you will make some kind of algorithm. If there is any match, okay, so then to the accuracy you will set a threshold, maybe more than 95% correlation, or you can say that the error is less than 5%, then it will okay. What the error? We already studied is a linear regression, okay? Y minus Y, okay, bar somehow. We already studied a lot the least square error, so difference should be less. Minimize the difference. If difference is very less, then okay, you say that it's somehow corrected and the matching, okay? So your object detection look like this. Is it clear, please? Yes. Question? Sleepy, tired?
No,
Yes, please.
So will it compare the test image with whole data?
Yeah, actually, what is that? Okay, there are suppose just suppose in the M, this is the okay learning data, augmentation of the data, keeping the 9 images, nine images. Suppose this one is the 9 images in this data, and your test data is the one. Okay, one after recognition make 1M, single M. This one is the 1M and this one is the okay. Also, this one is the test. What will happen? First, it will okay match scale error. Okay, this scale error with one okay store value with one. So, of course, for example, is Bilal. This is one is the belong to the Aftab. The difference is what? Error too high. Just ignore it. This will ignore it. Okay, again maybe it's Sham. Ignore it. Maybe so. Maybe it's the Bilal. Yeah, Bilal. Maybe more than 95% chance, or maybe error is very less. You can say that the 5% error. So you say it's okay. Similar. It may, then what will happen if your accuracy threshold, please, I'm back, you don't see, okay, please, just, if threshold, at this point, threshold will match that this test image belongs to the Bilal, okay, feature, okay, everything label, okay, belongs to the Bilal, then pruning, my children, pruning,
yes,
no
sir.
need to go further. Clapping for Numan, come on. Yes, cut off. So completion card. If not, threshold will not match, then it will go further. Okay. Yes, please. Irfan. Oh, I'm so sorry. Come outside. Come outside. Today he will Today we will listen to you. We are eagerly waiting for you. Yeah, please. Once again, clapping for Irfan. Believe me. Very good boy, very hardworking and very genuine boy for learning AI. Yes, please. Please.
अगर हमारे पास यहाँ पे फर्ज करें कि 10% आ जाता है,
Yes, please.
और यहाँ पर अगर हम कंपेयर करते हैं तो यहाँ पे हमारे पास 8%.
Yes,
तो
please.
फिर कौन से वाले वोट हैं?
So you mean to say no? You mean to say 10% is error or what?
Error sir, match.
10 error. 10% is a higher, bigger error. Okay. you want to reduce that error should be less than 8 or less than 8, then it will go further. If you say you set threshold
Yes, sir.
that 10% error is okay, then it will stop there.
No, sir. हमारे पास अगर हमने threshold 10% रखा हुआ है,
For okay.
उसमें